Welcome back. Last video we went over upper bounds and lower bounds, and we were comparing equations both graphically and algebraically, and I used Wolfram Alpha as a tool. I just wanted to walk you through that, show you how to use it, because it's helpful in understanding asymptotic analysis at a conceptual level, and if you're confused about how to visualize something, plotting it in Wolfram Alpha will often help you determine if something is an upper bound or a lower bound or somewhere in between. So here we are with Wolfram Alpha, and let's say we're comparing two equations, x and x squared. So we just want to plot those. We're just going to say graph x squared. We'll use the caret for exponentiation, and we'll graph it against x. And then we can also specify a range of x. So I'll just say x from 0 to 10. I'll hit enter, it will graph it, and here's the plot. And we can see the blue line is x squared, and the red line is x. X is pretty noticeably larger, and it's definitely growing at a faster pace than x. So maybe we want to verify if x squared is really larger when it gets gigantic. So we can just make that a larger value. And we'll see that we can't even see x anymore because x squared just grows so quickly. And oftentimes you can figure out simple equations like x squared and x, but what if we had to compare x versus x times the cosine of x? That's a little bit more challenging and harder to visualize unless you think about it for a little while. So we can graph it. Let's say x versus the cosine of x. Now, one thing to remember in computer science is we're only concerned with the positive values of equations and positive equations in general. And the same is true for asymptotic analysis. So whenever we compare functions, we always want to compare the absolute value of the functions. So we're just going to say absolute value of x times cosine of x. And we'll plot x from 0 to 10. That's usually enough to give you a good picture, but you can continuously expand the graph as needed. And so here we can see that it's just sort of oscillating, but cosine x never goes above x, so it seems. So we'll just make x go out to a really large value and see if that pattern continues. And it looks like it does. So it just, cosine of x just continues to oscillate up and down from 0 until x. And if we were to consider the behavior of cosine x, that makes sense. So here we can see that cosine x is bounded above by x, because x is always higher, and therefore x is an upper bounds of x cosine x. That's Wolfram Alpha in 3 minutes. So graph function, you can plot as many functions as you'd like with this graph function. We can do x and x squared, x, absolute value of x, x squared. And we can also specify a range by just saying x from 0 to whatever. And as I said before, generally in computer science and with asymptotic notation, we're not concerned with negative equations, and we're only concerned with very large values of x, as x gets very, very large. And because of that, we don't care about the negative portion of the graph, and we always care about the absolute value of a function. So there it is. Next time we will cover asymptotic analysis starting with big O. I will see you next time.